Okay, so we're factoring trinomials of this form ax squared plus bx plus c. Same form as yesterday. What's different? Now, the a is not 1. So there's going to be a number in front of the x squared. Okay, that's all that's different from yesterday. Yesterday, we may have had numbers in front, but we could common factor them out. Now, we might not be able to. Okay, so the first question, I asked you to just expand those out. That's not factoring, that's expanding, right? That was last week. But we want to look at some patterns from this. Take a look. When we do that, we multiply the first terms in each bracket together, and we get 10x squared. So when we're asked to factor, we're going to be going backwards. So we're going to need to find two factors of 10x squared. Obviously, each of them has to have an x, and then the two numbers have to multiply to 10. So either 10 and 1, in this case, it's 2 and 5. Okay, then what do we look at? The outside is 15x, and the inside is 4x. Remember how yesterday when we found those two numbers that multiplied to the constant, they added to the middle term. So the outside and inside add to that middle term, these two. But notice how those 15 and 4 don't multiply to 6. Okay, so if we were going backwards and finding, splitting this up, they don't multiply to 6. But 15 and 4, what do they multiply to? What's 15 times 4? Just tell me. 60. What's 10 times 6? 60. So the extra step that you have to think about today is that the two numbers that you have to find, they have to add to the constant, and they have to multiply to whatever the first and last terms multiply to. So if it's not a simple trinomial, they have to multiply to 60. Here, they have to multiply to 12 and add to 7. Well, two factors of 12 that add to 7 are 3 and 4. That's what those two middle terms are. Okay, so we're going to, that's just kind of setting you up for actually doing the factoring. So there's a proper mathematical method. It's called decomposition. Okay, think of decomposing something. It's breaking down into parts. Okay, so in this method, we're breaking down that middle term, that bx, into parts, two terms, not just any number of terms. You're breaking it down into two terms, and then you're going to, so basically it's going up to these, and then you're going to factor by grouping. Remember, we did that yesterday and the day before, factoring by grouping. So that's really these steps. So we're determining whatever AC is, the first coefficient and the constant term, and what B is. So we're finding two numbers that multiply to AC and add to B. We're decomposing the middle term into two terms, and then you factor by grouping. So those are the steps. It's sometimes easier not to look at the words, but to actually do it. So that's what we're going to do in this one. So if maybe don't copy it as we go, just watch me. Okay, so first step, is there a common factor? Anything that goes into 3, 7, and 2? No, those are all prime numbers. So then you go, okay, 3 times 2, that's 6. So I need two numbers that multiply to 6 and add to 7. Just like yesterday, except I have to incorporate that 3. So who can tell me two numbers that multiply to 6 and add to 7? William. 6 and 1. You can check it. You don't have to show that. But then for decomposition, we copy out the first term. We decompose the second term into 2. So 6x and 1x. You can put the 1 if you want. I don't care. Okay, then we are factoring by grouping. Okay, we did that yesterday and the day before. So in that first group, what's common between 3x squared and 6x? In that first red swoop there, Matei. 3 and what else? X, 3x. Okay, what are you left with when you divide that? X plus 2. Take a look. There's nothing common between the 1x plus 2, but funny, it's the same as the bracket. So you can almost consider factoring out a 1, even though that doesn't do anything to it. But for starters, for the first few questions that we're doing, might as well to see that it's exactly the same. Now look at those brackets. Are the brackets the same? Yes. That means you chose the numbers correctly. If they're not the same, you did not choose the numbers correctly, and you need to go back and think again. Or maybe you can't factor it. Okay, so now when I factor out the x plus 2, just like we were doing, so hopefully you've done your homework, we factor out, so we're dividing everything by, I'll do it in green, by that greatest common factor of x plus 2. Okay, and what we're left with is the 3x, so these divide out, right? So you're left with 3x plus 1. Okay. How can you check your work other than redoing the whole factoring again? Multiply it out. So first terms together is 3x squared. Outside is x. Inside is 6x. Last is 2, which is 3x squared plus 7x plus 2. So you know you got it right. Okay, that's how you can always check. Sometimes students are better at expanding than factoring, so that might be a good reason to use expanding to check. Okay, so that's 3 steps basically for decomposition. We're going to learn a little bit faster method, but it still goes through the same process of finding those numbers. So the finding the numbers part, if you need your calculator, get it out. You need to be able to find those 2 numbers. Okay, so here, 2, 3, and negative 20. Anything common to all of those? No. So it is not a simple trinomial. So we need 2 numbers that multiply to negative 40. Take the sign in front of the constant term, negative 40. And then those 2 numbers have to add to positive 3. So you can start. One obviously has to be positive, one negative. So 1 and 40, 2 and 20. Pardon? Yeah, I said here, 2 times negative 20. It's not a simple trinomial, right? So you have to multiply those 2 together. That's negative 40. So 1 and 40, 2 and 20, 3 doesn't go in. 4 and 10, 5 and 8. So 5 and 8 have a difference of 3. Which one needs to be positive and which one needs to be negative? 8 needs to be positive. Okay, so I'm going to rewrite. So this one is positive, that's negative. So that's my pair. So here I'm going to rewrite this as 2x squared minus 5x plus 8x minus 20. And I'm just going to erase this part here. Okay, then I'm going to just group them in order. And so between 2x squared and 5x, any numbers common? Nope. Any x's? Yeah. There always should be an x that's common in the first pairing if they're in descending order of degree. So x is common. I'm left with 2x minus 5. Okay. The next term, whatever it is, take the sign. If it's positive, you put a plus. If it's minus, you put a minus. Sometimes students just don't put anything, and then it means multiplying. So what's common between 8 and 20? 4. So we're going to factor out a positive 4. I'm just going to erase this for now. And when I do that, positive 8x divided by positive 4 is 2x. Negative 20 divided by positive 4 is negative 5. How do I know I've chosen the correct numbers right now? William? Brackets are exactly the same. Okay, so I know that that's my greatest common factor of this is 2x minus 5. And then I'm just dividing out by the 2x minus 5. So I'm left with x plus 4 in my other bracket. Okay, so I'll give you a minute to make sure that that's copied down. Okay, you've got to have these steps for decomposition. On a test, I'm not going to say, oh, use this method or this method. Use whatever you want, because really, it's up to you. It's a 1-mark question. Okay, but this is a method. This is the sort of the true algebraic method of factoring. And then in the next question 3, we'll do a little bit faster. Once you've copied that down, take a look at C and check for a common factor. Hint, hint. Also for factoring, say on a test, if you want to show all this work, if you want to write down all those pairs of factors, don't take up all your test paper. I'll give you a piece of scrap when you do it there, right? As I said, it's sort of right or wrong. And so then you can write down all the possible factors until you get the right combo. What you need here is you need that common factor of 2 divided out. Okay, so when I divide everything by 2, I get 4n squared minus 9n plus 2. Then you look in that bracket. Is it a simple trinomial? Is the n squared term, the variable squared term, a 1 in front? No. So then that's this method where we have to decompose that middle term. So I'm going to put it down here. I need 2 numbers that multiply to 4 times 2. Okay. If you do it just with 2, it's never going to work. There's no way you can find two factors of 2 that add to negative 9. Right? So if you said not factorable, you're incorrect. So you have to look at that coefficient. So I need 2 numbers that multiply to 8 and add to negative 9. 4 times 2, the red. Okay. So look in front. Well, factors of 8, you can go through them. Your choices are 1 and 8 or 2 and 4, either both positive or both negative. Well, 2 and 4 doesn't work. So 1 and 8 where they're both negative. Okay, so this is what works. So now when you're doing your factoring, I'm going to change that just to a square bracket, just because I know I have to factor by grouping. If you have a bigger set of brackets, it's fine. I just like to have square. And then I copy out the first term. It doesn't matter which one you put next. So I'll just put it in order. So minus n, or 1n, minus 8n plus 2. Remember, minus n is the same as minus 1n. You say, I've got an apple, and I've got one apple, means the same thing, right? So you're factoring, just go in order. And so 4n squared and just minus n, obviously, n is common. Again, you're always going to have the variable as the common factor of the first group, if it's in descending order of degree. So n, I'm left with 4. Oops, let me fix my 4. Although some people write it like that, but 4n minus 1. Then whatever sign is next, I copy it out. Okay? Don't ever put a plus if it was a minus there. So between negative 8 and 2, if I'm factoring a negative, they're both even numbers. I'm going to factor out negative 2. And what am I left with? 4n minus 1. Okay, now some of you might by mistake put 4n plus 1, but hopefully then you look at your first bracket and you go, they're not the same. What happened? Okay, so then you fix that error, or you check back in your two numbers, but these brackets have to be the same. So now, again, I copy out the 2, I copy out the bracket that's the same, and then what's left when I divide by that common factor, remember those go away, I'm left with n minus 2 in my other bracket. Okay. So that's the method of decomposition, the algebraic method. In question 3, factoring the same using other methods, I'm going to use inspection or trial and error, or however you want to call it. You could go on YouTube, look for methods of factoring trinomials. You'll see something. There's a rainbow method. There's the box method. There's the Australian method. People have named methods after them. Okay. So there's a lot of different, some are the same method, but they just want to name it after themselves or whatever. When I first came to this school, some previous teacher had named a method after him. Whatever it is, they're all kind of similar, but what we just learned was the proper algebraic method. And then all of the other ones are fast ways. Okay? Fast ways are great if you can remember them. Okay, so practice, practice, practice. What I use for my fast method is, as I called it, inspection. And I think about how we get to an expanded form. That to start, we have to expand out two binomials. So I know here, this one, first we look for a common factor, there isn't one. But then, just like yesterday, I set up my two brackets. And then I look at my first term. So yesterday, I just put x and x, because it was always x squared. Now I've got 3x squared. Well, this is nice, because is 3 a prime number? Yes. So the only options you have are 3x and x. And certainly they can go in either bracket, right? Then you could look at the last terms and go, well, it has to be 2 and 1. Or negative 2 and negative 1. What I do from here is I still do that same step for decomposition. I still look for two numbers that multiply to 6 and add to 7. Okay, so anytime it adds to one more than the product, you know it's itself in one. So that's going to be 6 and 1, right? The thing is, you do not put, if I put 6 and 1 in here with a plus, don't write it. If I do that, right away I know it's wrong. 6 times 1 is not 2. Okay, so with, I'm kind of using part of the decomposition method. Oh, just a second. Just want to erase this. Okay, so I'm doing that on the side, just like if I was going to do decomposition, but I've set up my brackets already. So now I know that my outside terms, oh, at least the pen's working, I guess. My outside terms, there we go. My outside and my inside have to add to 6x and 1x. So is there any way that I can multiply 3x by something to get 1x and be a natural number? No. Okay, so that has to give me my 6x. So 3 times 2 is 6. And then to get a 1 here, that has to be a 1x. So I'm using the outside. So when you're thinking about FOIL as your acronym, I'm looking at the outside and inside and these two numbers to figure out basically placing the factors in there. No work needed. You do not have to show any work for it, just the answer. I showed my work on the side, what multiply to 6 and add to 7, but that's optional. Okay. So same with the next one. No common factor, but take a look at this one. 6x squared. Is 6 a prime number? No, it's not a prime number. So I don't know if I put 6 and 1 or 2 and 3. Okay, so I'm not going to put I'm going to put something x in, but I don't know what yet. And then my two numbers have to multiply to negative 12. Add to 1. Okay. So you can go through it. 1 and 12, no. 2 and 6, no. 3 and 4, yep. Which would be positive and which would be negative? 4 is positive, 3 is negative. Okay. So now my outside and my inside have to multiply to negative 3 and 4. Okay. Saying that, I have to have a product here that multiplies to 6. Okay. Is there either of these that has a factor of 6? Does 6 go into 3 or 4 with an integer? No. So I know I can't have 6 and 1. So that breaks it down to 2 and 3. Okay, so you have to have your sort of factoring skills. That's why we did that unit first. So that's the only choice. Again, you could put 3 in the first bracket, 2 in the second, doesn't matter. And now my outside, well, 2x, I can't get negative 3. So that's going to be for this one. So my outside will be a plus 2 here to get the 4x. My inside, to get negative 3, would be a minus 1. And then always expand back to check. 2x times 3x is 6x squared. Plus 4x minus 3x is 1x. Negative 1 times 2 is negative 2. Okay.
So how do you figure out the negative 1 and 2?
From these two numbers, my outside for FOIL has to multiply to either negative 3 or 4, and the only one it could be is 4, right? Because 2 doesn't go into 3. Okay, so next one, set up the brackets.
2
is a prime number. It's a nice one. You can go 2n and n, and you've done part of your work already. Okay. Okay, then we look at, okay, two numbers that multiply to negative 30 and add to negative 1. So anytime they add to 1 or negative 1, they've got to be factors that are 1 apart. So what are factors of 30 that are 1 apart? 5 and 6, right? So if I put 5 and 6, which one has to be negative? The 5 or the 6? They have to add to negative 1. Tolu? But yeah, the 6. 6. The bigger one has to be negative to add. So negative 6 and 1. Oh, sorry, not 1. Negative 6 and 5. Add to negative 1. Okay. So they multiply to negative 30, add to negative 1. You don't put them right in because this is not a simple trinomial, right? So what happens, that's a little messy. I'm just going to rewrite that, just the two factors. So negative 6 and positive 5 are the two factors. So I have to get those two numbers when I multiply my outside and my inside. Just a sec here. Try to get, there we go. My outside and my inside. So is there anything you can multiply 2 by to get 5? If it's a natural number or integer? No. So obviously I have to do the outside has to give me negative 6. So this would have to be negative 3. 2 times negative 3 is negative 6. And then my inside would have to be plus 5. No choice. Okay. Can I what? Sorry? Yeah, of course. I'm going to do D. Yep. Okay, so expand that out to check. 2n times n is 2n squared. Minus 6n plus 5n is negative n. 5 times negative 3 is negative 15. Now. Yeah, absolutely. Okay. If you want to go online and find something, just any kind of work that you do, I would just do it separately and just put your answer in because there's really going to be a one mark, right or wrong. This one back up here, this would probably be 1.5 to factor out the common factor and then do it, the trinomial, right? So that's worth a little bit more. So I do need to see that work. This one here, the D, nothing common. Nice again because 3 is a prime number. So it's already 3x and x. Okay. And so this inspection, I want to multiply to negative 28 and add to negative 2. So negative 28 and add to negative 2. Not 28, sorry, negative 24. Sorry, negative 24. So I'm going, there ain't one for that. Okay, so what two numbers multiply to negative 24 and add to negative 2? Miles. 4 and negative 6. Okay. So then I'm looking my inspection to get those outside and inside. So 3 doesn't go into 4. So obviously my outside has to give me negative 6. 3 times negative 2 is negative 6. And my inside has to give me 4, so that will be positive 4. Okay. So then on the next side. Okay, so you to try question 4. I'll give you a few minutes to work on those. Okay, so these are the answers. You don't have to show any work unless there's a common factor first. Take a look at C, and you'll notice that each of those brackets is exactly the same. So you could show it as 3p plus 2 squared. You don't have to, but you can, because both of the brackets are exactly the same, and they're multiplied together. That's what an exponent power is, repeated multiplication. If you take a look at E, you common factor out the 3, and then you're stuck finding two numbers that multiply to negative 30 and add to negative 4. I went through all the pairs of factors. One would have to be positive, one negative, but no matter what, none of them work. So that is as far as you can go, is to factor out the 3. Don't say it can't be factored in this case, because you did factor. It was just a common factor and you're done. Okay? And then in F, there's a common factor and you can factor again. So in order to check, I recommend that you multiply the binomials together first and then multiply through by 10. Sometimes students will distribute the 10 into both brackets, and that's incorrect. So I would expand that back and just make sure it's the same as this first bracket here. Okay, and then multiply through by 10, and hopefully it's the same. Okay, so practice, practice, practice. Expand back to check. There's always a way of checking. And if your last terms don't multiply to that constant term, then obviously you did something incorrect, something wrong. Okay, I was talking with a student, asked how many times on the volleyball team do they practice serving? 100. Okay, each practice probably when you add it up. Got to practice. So doing 6 questions of factoring is not enough, right? Over and over and over until you start getting to the point where you're not making a mistake. Okay, got to practice. All right, so let's finish off this set of notes. What did I just tell you? How can we verify that we factored correctly? What did I say to do? Someone said it over here. Expand, multiply. Either one, expand back, multiply back. Multiply the factors. Okay. If you don't get the original, then you did something wrong. Now, I guess you could make a mistake in multiplying, but usually students are better at that. Okay. So verify your factors from question 4A. That was 2a plus 1, a plus 7. Okay, so expand it back. Now, notice you might have had a plus 7 times 2a plus 1. They're the same. Right? If you go 3 times 4, that's the same as 4 times 3. Order of multiplying doesn't matter. These are the same. So either way, it's correct. Okay, and then when we expand back, 2a squared plus 14a plus a plus 7 is, oops, let me just press something. That's what I just pressed by mistake. Equals 2a squared plus 15a plus 7. Okay, what did we just figure out? Can all trinomials of this form be factored? Did we have any that couldn't be factored? Yeah, we did. That's the last one, right? In, what was that, E? So no, not all of them can.
No.
Okay, so explain how you would know if a quadratic of the form, that form that we've been doing, is factorable. You have to be able to find those two numbers. So it is factorable. I'll try to write nicely. If there are two, I'll call them integers rather than just numbers, because we don't use fractions or decimals. If there are two integers that multiply to AC, okay, Miles, stop, and add to B. I'll put little quotations around AC and B. So give another two examples of trinomials of the form ax squared plus bx plus c that can't be factored. Well, there's many that you could do. Okay, so whatever you decide might be different from me. How about I start with something like, I don't know, 5x squared plus, I'll go 10x, okay, and then plus a number, so that the product, so let's say I choose 2. So I would need two numbers that multiply to 10 and add to 10. Is there any way that you could do that? Have two numbers that multiply to 10 and add to 10. If we're dealing with integers. No. So there we go. There's an example. So if you make the outside product the same as the coefficient of the inside, that's one way of finding one that doesn't work. There's an infinite number of ones that don't work. This says find two examples. So now maybe I'll do, I don't know, I'll do a 3x squared. I'll put a plus 6x. And how about I put just plus 1. Okay. So now I would be looking for two numbers that multiply to 3 and add to 6. Well, how can you get that? With a small number and then adding to a much bigger is never going to happen, right? 3 and 1 is 4. And that's the only choice. So that would be another one that works. Okay, so then the opposite of that. So we just found two that don't work. And then it says in 8, state all possible values for k so that the trinomial can be factored. So take a look where k is. K is the b value. So we know we need two numbers that multiply to 6 and add to k, the coefficient of x. So in this case, we have to find all the possible, that's a hint, there might be more than one k value. So factors, we always start with factors. So factors of 6. Well, what are they? They could be 1 and 6, 2 and 3. Are there any others if we consider negatives that multiply to positive 6? What if they're both negative? You get a positive?
Oh, yeah.
Yeah. So you could have negative 1 and negative 6, negative 2 and negative 3. Maybe I'll put them underneath here just a sec. Oh, sorry, just a sec. Oh, there we go. Okay, so then if we, then our k value, if we put those numbers back in to add them together, well, 1 plus 6 is 7, 2 plus 3 is 5, negative 1 plus negative 6 is negative 7, negative 2 plus negative 3 is negative 5. So there's 4 possible k values. positive and negative 7, positive and negative 5. And so we can show that fast form. Have I showed you that before? We were put a little plus and minus vertically. That's a fast way of writing numbers out where you have both of them, the positive and the negative. But you can certainly just put commas in between. Okay, but we often ask that on a test. Okay. Yep. Or which one is not a possible value, that kind of thing. Can you sit up, please? So, same thing for the next one. Two numbers that multiply to negative 5. Now they're multiplying to a negative and adding to k. Oh, I've missed the negative there. Okay, multiply to negative 10. So, that means we could have 1 and negative 10 and negative 1 and positive 10, right? Either one could be negative. Then we could have, what's another pair that works? Someone else share. Yep, good. Negative 2 and positive 5, and then positive 2 and negative 5. No other choices. So now when we add those together, we would get negative 9. Here we get positive 9. Here we get positive 3. Here we get negative 3. Okay. So there's 6 possible values for k. I can summarize it plus or minus 3, plus or minus 9, or you could certainly just leave it as I did. So, take a look. There's a bunch of practice on the back of that. Yep. There's the practice on the back, and if you take a look at today's lesson, it's Wednesday, page 177. There's practice questions there. We'll be tomorrow looking at special polynomials. Okay, so again, trinomials, but they're just a little bit more special than today's one. Okay. Well, tomorrow's Thursday, so we'll look at those and difference of squares. Then it's the weekend.
Oh yeah, check-in tomorrow.
And we'll have a check-in tomorrow.
On
I think we'll either have it tomorrow or Monday.
Is it on what we just learned today or everything we learned today?
It's everything on factoring we've learned. Okay, folks, listening, please. Okay, so Monday is basically review, and then Tuesday is full-on review, and Wednesday is full-on review. So really by tomorrow, we'll have learned all the methods. Just when it says on Monday, factoring trinomials involving two variables, it's the same method, but you might have X's and Y's in it, or M's and N's. Okay? Yes, ma'am. So, lots of homework, practice work this weekend.